Right, some more floating point binary. This is question 20 from the course book. There's actually 4 steps, 4 questions to this. So the scenario is the denary number 10 3/4 is to be represented as a floating point binary number using 12 bits. The first 8 bits are used for the mantissa and the remaining 4 bits are used for the exponent. So first thing I'm going to do is lay out my columns. Okay, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 12 potential digits that we can use. So the first 8 bits, okay, from here, 1, 2, 3, 4, 5, 6, 7, 8. The first 8 bits, try and draw a straight line. Are used for the mantissa. These 4 bits are used for the exponent. So what is meant by the mantissa? What is meant by the exponent? Well, very briefly, the number that we're trying to explain or show is 10 3/4. Okay, so we're given a number and we have to explain why it is a floating point representation of this. Okay, so the number we're given is 0, 0, 1, 0. 1, 0, 1, 1. Okay, that's the mantissa part. The exponent is 0, 1, 0, 1. So we're given this big, long 12-digit number. Okay, but from the question we know that these digits are the mantissa and these are the exponent. So how can we explain that that is a representation, a floating point binary representation of this? The first part is pretty straightforward. So what I'm going to do is add these numbers together, okay, or figure out the binary for these numbers. Now what I should have done, or what I could have done, would be to number these columns rather than putting the zeros. Okay, so we know that the binary is actually, this is the 1s column, 2s, 4s, 8s, because we're doubling up every time. Okay, and that, if that was one long number, we would continue, but because the mantissa is different, then we're going to use the start the columns again from here. Anyway, the exponent is 1 on the 1's column, 1 on the 4's column. Okay, so the exponent equals 5 at this stage. Okay, now this, the mantis, is basically the number that we have. Okay, the exponent is the fractional part. If we're saying positive 5 here, we do this, start here, and we go 1, 2, 3, 4, 5, and we put a decimal there. So the number now becomes, a different colour, the number now becomes 1, 0, 1, 0, 0.11. Okay. So again, we can put in the columns here. Now this is our positive integer, this is the negative side. Okay, so we've got positive 1, 2, 4, 8. So 1, 2, or 1, 8 is going to give us a denary of 10. Over here we have the negative part, okay, which is I need to pick a different colour, which is 1/2, 1/4. If we were to continue, we would be doing this. Oops. Okay, so we only have 1/4, sorry, 1/2 and 1/4. Okay, which works out as, to get the lowest denominator, 1/2 and 1/4 obviously is 3/4. Okay, so in an exam, that apparently is a 3-mark question. And their marks would be awarded like so. Okay, so we get 1 mark for moving the decimals. We get 1 mark for working out this. And this. And we get 1 mark for adding the fractions. You could have said 1/2 plus 1/4 equals 3/4. Okay, so we get marks for the working out. Now, if if we go right back to our number, sorry, I've missed a step. If we go back to our number here, the next step of the question, and I'll do this in a separate video, is to normalize this number. Okay, so at the moment it's not a normalized number, and we'll explain why in a minute.